Hi guys, Mr. Janowski here. So I'm going to take another crack at this because I'm not real happy with the way the last video came out. So this is the study guide for Chapter 9, Problem 3. So we've got a block. It's sliding towards a spring. It's going to compress the spring, come to a stop, um, and we're going to try to figure out some things out about it. So first, how much kinetic energy does the block have before it reaches the spring? Second, if all of that kinetic energy is converted to elastic potential energy when the block momentarily comes to rest against the spring, how much elastic potential energy will there be in the spring? Third, what will be the spring's compression at that instant? So when the spring has brought the block to rest, what will be its compression? Fourth, what would be the kinetic energy of a second block? So an entirely different block with 1/4 the mass of the first block, but twice the velocity. And then finally, how much would that block compress the spring? So let's take a look at this. So as usual, we'll start off doing step huh. So step huh. Part A, what are we looking for and what units do we expect? We want to know the kinetic energy. So question mark, the units for that will be joules. For B, if all of that KE is converted to EPE, blah, 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 how much EPE will there be in the spring? So next we're looking for EPE. That will also be question mark joules. C, what will be the spring's compression at that instant? So what's our symbol for compression? It is X. So X is question mark, and the units for X will be meters. D, so for parts D and A, we're dealing with a separate block with a separate velocity, and we're trying to figure out similar things about it. So what would be the kinetic energy of this block? So KE equals question mark joules. And then finally, how much would this block compress the spring? So what's the compression of that other block? So let's see, how are we going to do part A? How much kinetic energy does the block have before it reaches the spring? So A, KE equals 1/2 m v squared. We know the mass, we know the velocity, so this shouldn't be that hard to do. So KE will equal 1/2. All right, that's a half. Our mass, 8 kilograms. Our velocity, 3 meters per second. And that gets squared. And if you do all that, you're going to get KE equal to 36.0 joules. Put a box around it, and then quick step, does it match what we were looking for? Yeah, we wanted kinetic energy in joules, and that's what we found. So we're happy about that. So on to part B. If all of that kinetic energy is converted to EPE when the block momentarily comes to rest against the spring, so this block is going to hit the spring, slow down, come to a stop just for an instant, and that's where we're going to stop our problem. It's after that, we imagine it's going to push, the spring is going to push it away back towards the left, but we don't care about that. We care just at the moment when the block momentarily comes to rest. So let's see. How much EPE will there be in the spring? We're looking for EPE. If you read this problem carefully, if all of that KE is converted to EPE, yeah, you don't have to do a whole lot of work for this one. What I said there is kinetic energy, kind of kinetic energy initial. I can dot my I's better than that. Barely. All right, perfectionist here. That's worse. We're going with it. Kinetic energy initial is equal to EPE final. Well, we already know what that is. We just solved for the kinetic energy. So really what we have is 36.0 joules is equal to EPE final. Yeah, you don't really need to do a whole lot of work on that one. As long as you're reading the question carefully and understanding what it's asking you, that's pretty straightforward. So does that make sense? Yeah, we got the right thing. We gave it the right units. So I'm giving it a check. I forgot to give the first one a check. I won't do. There we go. Now it is a check too. The next question. Get rid of these guys. Let's see. What will be the spring's compression at that instant? So we're looking for X, the compression. So part C. How are we going to get X? Well, if you look at the footer of the homework, of the study guide, of everything, you'll see the formula for EPE is EPE is equal to 1/2 kx squared. So the thing we're looking for here is X. So we've got to do some algebra to get X by itself on one side. And what's that going to look like? Well, first multiply everything by 2. That will kill off the 1/2 on the right side. And that'll give you EPE is equal to kx squared. And then divide everything by k. That gets rid of the k on the right side. And then all of this would be equal to x squared. But then, how do we deal with the squared? Just take the square root of both sides. If you do that, the squared goes away, and you end up with this over here. So if we plug in our numbers, that should get us to the answer. So what we would have is x is equal to the square root of 2 times, remember we just figured out what EPE is equal to. It's 36 joules. All of this divided by k, and k is our spring constant. That number right there, 1152. It shows that number very carefully to get a nice answer. Newtons per meter. Put that in the calculator, and what you'll end up with is x is equal to 0.250 meters. So a quarter of a meter. So think of a meter stick. Imagine how big a quarter of that is. And that's your answer. That's your compression. So we solved for the right thing. We gave it the right units. I'm giving it a check. On to part D. So in part D, go away. Okay, part D, well, let's change colors. No real need to, but it's fun. What would be the kinetic energy of a second block? So this is a completely different block with 1/4 the mass of the first one and twice the velocity of the block in part A. So for part D, let's see what we know. We know that this block has 1/4 the mass. So the mass of this is 1/4 the mass of the block in parts A through C. Well, that was 8 kilograms, so this must give us a mass of 2 kilograms. And our velocity is twice that of the block in part A. So 2 VA. Well, that was 3 meters per second, so this must be 6 meters per second. And we're trying to solve for kinetic energy in joules. So what's that going to give us? Well, remember your formula for kinetic energy. KE is 1/2 mv squared. So that makes it 1/2 times 2 kilograms times 6 meters per second squared. Put that in the calculator. Well, see if we can do it without the calculator, actually. 1/2 times 2 gives you 1, and 6 squared gives you 36. So go ahead, use the calculator if you need to. But you're going to find out that your answer is 36 joules. So put a box around it. We saw for the right thing. We gave it the right units, so give it a check. Now let's think for a second before we go into part E. How much will this block compress the spring? Well, once again, all of the kinetic energy we have is going to be converted into elastic potential energy. So maybe you can kind of see where this is going, even if you didn't already see the answer right there. But yeah, let's try to do this. So we're starting with a kinetic energy of 36 joules. Let's get a new layer, get rid of that one. Change colors for no reason. And then part E, let's see, what do we know? We know that all of that kinetic energy is going to become EPE, and we already know that that kinetic energy is 36 joules. So once again, let's go to the formula for EPE. EPE equals 1/2 kx squared. Hopefully I can get through this video. I just got the warning that I'm running out of memory. So again, we're going to do some algebra. We're going to end up in exactly the same place. Let me go back. We're going to end up in exactly the same place, which is x is equal to the square root of 2 EPE, which is 36 joules, divided by K. And if you plug in the numbers, you should find that x is equal to 0.250 meters. So sorry I'm rushing through this, but I'm getting the warning that my Chromebook's about to run out of memory again. So hopefully it lets me at least record this video. Whoop. Okay, I'm watching the warning. Yeah, so hopefully it's not too surprising that we get the same compression. We started with the same initial kinetic energy. All of it became EPE, so we should get the same compression. So hopefully that helps.